welcome guys. We're on 8-5 practice and problem solving over the mean absolute deviation and the interquartile range. For the interquartile range, you put your data set in order from least to greatest, and then find the median, and then you find the middle of the lower half, find the middle of the upper half, and then you subtract the middle of the upper half minus the middle of the lower half. To find the mean absolute deviation, Bubbles, what you have to do is first find the mean. Once you find the mean, you find the absolute deviations away from the mean. And then once you find the absolute deviations away from the mean, you find the mean of those absolute deviations. That might be all you need from me. Bye. No, I'm just kidding. I will walk you through every problem, even though my numbers are different. That's okay. That's okay. You will know the process, and I'll help you give you tips and hints because this is my fourth time doing this. I'm about ready to go a little crazy. At first, we were outside making the video. Things were going well. Then we were inside, and then my kids are running around. I don't want them to distract us from getting our work done. So here we go. Now, absolute deviation of 1. So when deviations go down, it's going to be negative. When deviations go up, they're positive. But with absolute deviations, they're all positive, okay? So the mean of the data set is 3. So deviations, again, mean the distance from the mean. So 3 to 1 is how far? The deviation is -2 because it's 2 away. And the absolute value means the distance from 0. And that is absolute value of -2 is 2. So the absolute deviation of 1 away from 3 is 2. Now, the mean is 3, and it goes to 4. It goes up 1. And the absolute deviation of 1 is 1. And from 3 to 6, the absolute deviation is 3. So right there, that probably saved you a lot of time. Because I didn't really remember this until I had to teach it. So I know your parents might not remember what the mean absolute deviation and all this means. So hope this helps you because we don't want to be bothering our parents with all this. They got work to do and stuff too. Although I'm sure they're happy to help. I kind of like being there to help you, seeing that I'm the teacher. The mean is blank. So use the data table showing the number of miles Jen walked on 9 days to find the mean. So we're going to add up all these and divide by 9. So we're going to add them all up and divide by 9. Use a calculator if you want. $72. I got 72, and then I'm going to divide by 9, and I get 8. So 8 is the mean. I bet we're working up now. Once I have the mean is 8, in your next question, there'll be the exact same numbers, I think. Are yours the exact same numbers, guys? I think mine are. Now I'm going to find my mean was 8, so I'm finding the absolute deviations away from 8. So 5 is 3 away from 8. 7 is 1 away from me, and 13 from 8 is 5 away. So absolute deviation of 5. And now I have to find the MAD. Now, here's how you find the MAD. What I want you to do on your paper is you could make a T-chart. Make a T-chart. These are your data values here. And these are the absolute deviations away from your data values. Okay, that's what I do. So I'm just going to write my numbers down. I always count just to make sure I have them all. And now, my mean was 8 in my case. I'm now going to go through and find the absolute deviations away from 8. So 8 away from 8 is 0 away. This goes down 1. -1 deviation to value of -1 is 1. Remember absolute value? These are absolute value signs. So remember that. From 8 to 11, From 8 to 11 is 3. From 8 to 13 is 5. From 8 to 5 is 3. Deviation of 3. Absolute deviation of 3. From 8 to 6 is 2. From 8 to 9 is 1. Where's Bubbles? Where'd he go? Oh, there he is. He's right next to me, guys. Don't worry. He's right next to me. From 8 to 12 is 4. And from 8 to 1 is 7. Yeah. All right, now to find the MAD. Yeah, Hudson, this is a really important part. So in order to find the MAD is we have to find, remember, we have to find the mean. We have to. Okay. In order to find. Say hi to everyone.
Not to you. Hi, everyone.
In order to find the MAD, what you have to do is you have to find the mean of these absolute deviations. So not so bad, right? Oh. Okay.
Bubbles?
He's okay. All right, so we're going to now find the mean. Add all these up. Not these. Your absolute deviations up. And divide by 9. All right, so I like doing this. 4, 8 plus, that's 10. And then this is 12. And then add those up. And I got 12 and 4 is 16 plus 10 is 26. So I got 26 here. So now you do 26 divided by 9 because there are 9 here. 26 divided by 9 is 2.88888 repeating, if my memory serves me. All right, put those back. All right, now this next part, what you're going to have to do is, what does the MAD tell you about the number of miles Jim walked? Select the correct choice below and fill in the answer box to complete your choice. So this is important. Decimal rounded to 1 decimal place as needed. So 2.888. Let me show you what 1 decimal place looks like. I don't want to assume you know. No, we don't. So the MAD is 2.8888 repeating, and then we're rounding to this place. So this 8 tells that 9 to go. This 8 tells that 8 to go to a 9. So 2.9 is what it is rounded. So basically what that means, if the mean is 8 minus 2.9, and then 8 plus 2.9, as long as if it's 2.9 away from the mean, you're within the mean absolute deviation. So the number of miles Jim walked each day varied by about 2.9 from his average. That one could be it. The number of miles Jim walked each day varied by about 2.9 from the maximum miles. No. The number of miles Jim walked each day was about 2.9 less than his average or more than his average. So, or more than his average. So it's varied about 2.9 plus or minus away from his average. That one. Hudson, what you doing back there? Uh-oh. Be careful with those.
I need to put the blue one in a white.
Now the interquartile range. So first, in order to find the interquartile range, the middle 50%, we're going to put these numbers in order from least to greatest. So go ahead, guys. Put those in order from least to greatest.
Sorry, Dada.
That's okay. All right, we just put the numbers in order from least to greatest, and Crosby's going to take Bubbles back to his cage.
Say bye-bye to Mr. Bubbles.
Thank you for putting him back safely. Make sure
hey, guys, look at that little face when I do this. Look.
Okay.
Let's see.
Don't squeeze it too hard. All right, so once they're in order from least to greatest, I made sure I counted. I got 10, and then I counted here. Make sure everything's lined up, because putting them in order from least to greatest is a pain, isn't it? So now you find the median, which actually will come between two numbers. And then once you have that median, you add them up and divide by 2. In my case, it will be 34. See how 32 and 36, 34 is right between? But you don't even really have to do that at this point. All you have to do is find the middle of the lower half. And I used the 32 to do that. I got 28 and 42. So now you take the upper quartile 42 minus the lower quartile 28. So third quartile minus first quartile. And then you get 14. So the interquartile range, guys, is 14. Oh, okay. How do the middle 50% of the prices vary? Well, it goes from 28 to 42. The middle 50% of the prices vary from 28 to 42. That kind of gets rid of all the outliers. When you find the interquartile range, it gets rid of all of them. Okay. The mean absolute deviation of a data set in the table is about 6.7. Does the value 15 deviate more or less than most values? So if the mean absolute deviation of the data set is 6.7, we need to find the mean of this data set. So in order to find the mean, I'm going to add all 9 of those numbers up and divide by 9. So again, guys, what I'm doing is I'm adding up all of these numbers and finding the mean. You add them up and divide by however many there are, in this case, 9. I lost my spot and I have to do it again. Okay, I got 162 and I'm going to divide by 9. My mean is 18. Now, 6.7 is the mean absolute deviation, or the MAD. So I'm going to do 18 minus 6.7. And anything 11.3. So does 15 deviate more or less than most values? 15 falls within the mean absolute deviation. So 18, from 18 to 15, that deviates less than most values, because look at some of these deviate a lot, but 15 and 18, that's only an absolute deviation of 3 away. Or 18 minus 6.7 is 11 point. Does the value 15 deviate more or less? So it deviates less, I believe. Oh, thank goodness. The data set shows temperatures recorded during a lab experiment. The temperature of the chemical solution was recorded in degrees Celsius every 4 minutes. What was the mean temperature for the solution? What was the mean temperature for the solution? So what I'm going to do is add all those up and divide by 8. And I'll pause it here while I do that. And so I added them up and divided by 8. I got an average or a mean of 32. Might have done it wrong. Hold on. All right, I forgot a number. So the average or a mean is 16. He's in his cage, buddy. So now Bella said, hold on, Huddy, can you go with mommy, please? Bella said that the greatest absolute deviation will be found from the greatest temperature because it has to be the farthest from the mean. Is she correct? Well, it's not from the greatest temperature, that's for sure. It's from the mean. Bella said the greatest absolute deviation. Oh, yeah, wait. Bella said that the greatest absolute deviation will be found from the greatest temperature or the least temperature. Or it could be away from the least temperature. Because you don't know. So I'd say no, because wait, let's see. So it's in this case. All right, so let's look in this case. If the mean is 16, the smallest temperature is 10, and the highest temperature is 21. So 16 to 21 is 5 away. 16 to 10 is 6 away. So it would be, in this case, the lowest temperature has the greatest absolute deviation from my case. The correct term is and its value is set. Okay, well, let's read this. What is the term used to describe the range of the middle half of the data? Oh, we know that, guys. The middle half of the data is the interquartile range, and its value for this data set is, so now I'm going to find the interquartile range. Almost done here, Frozen. Almost done. So put the numbers in order from least to greatest. Put the numbers in order from least to greatest. So I'm going to pause. And I have them in order from least to greatest. I made sure to count 8 and 8. And watch how I find the interquartile range. First, find the median. The median comes between 15 and 16, so it's 15.5. Okay, great case here. Great case study. Because look at this, guys. Watch this. When I come to here, I come between two numbers. So what you have to do is add them up and divide by 2. 14 plus 15. 14 plus 15 is 29, and 29 divided by 2 is 14.5. So the first quartile is 14.5. Then we go here, 18 to 19. You come between these two, add them up, divide by 2, and you get the third quartile is equal to 18.5. 18.5. So what we have to do then is find. All right, so what we do is we find the difference. 18.5 minus 14.5, and I think that's 4. That's a difference of 4 for the middle 50%. And now the MAD for the data. Oh boy, what did we say? Okay, so we said, guys, that the mean was 16, right? So now here's my suggestion. What you do to find the mean absolute deviation, is this. Ready? Here we go. The data values and then the absolute deviations. The mean for me is 16. So set this up on your paper. I'm going to write all my data values down. And now I'm going to, 16 is how far away from 10? That's 6. 16 is how far away from 16? 0. 16 is how far away from 19? That's 3. 2 away, 1 away, 2 away, 1 away, and 5 away. Now, I have all the absolute deviations. Once you have all the absolute deviations, you add them up and divide by however many you have, which is 8. So 9, 10, 11, 12, 13, 14, 15, 20. So 20 divided by 8. We have 20 divided by 8. Just going to use a calculator for that. 20 is 2.5. So the MAD is 2.5. And now, what does it tell you about the temperature of the chemical solution during your lab experiment? Select the correct choice below and fill in the answer box to complete your choice. So it tells you from 16, it's 2.5 less than 16, and 2.5 more than 16 would fall within the MAD, the mean absolute deviation. So let's see. The chemical solution was about blank less than the mean? No. Or more, less or more. Chemical solution varied by about blank from the mean? Probably that one. The chemical solution varied by about blank from the maximum. No, not from the maximum, from the mean. Solution is about blank more than the mean temperature or less. So this varied more or less and 2.5 away. If yours is repeating, make sure to round it to the nearest tenth, nearest closest decimal. Okay, next question. All right, it looks like we're doing the same thing. So you're going to get lots of examples of this. The data value shows temperatures recorded during a science test. The temperature of a chemical solution was recorded in degrees Celsius every 8 minutes. What was the mean temperature for the solution? Let's take a look. Let's take a look here. All right, guys, here we go. Temperature of the chemical solution every 8 minutes. What's the mean? So we're going to find the mean. I'm going to add these up and divide by however many there are. I'm going to pause it. So I added them up, divided by 8, and I got 18 as my mean here. So I suggest writing mean is 18. And now that we have the mean is 18, we can do this. Kyle said the greatest absolute deviation will be found from the greatest temperature because it is the farthest away from the mean. Is he correct? So what's the greatest and what's the least? Let's see here. 12 is the least. So that's an absolute deviation of from 12 to 18 is 6. And the highest is 23. And that's an absolute deviation of 5 away. So it's actually not the greatest temperature, but the least temperature in this instance. So is he correct? No, because the lowest temperature has the greatest absolute deviation. The correct term is the blank and its value. Okay. Oh, the range of the middle half of the data. Find the value. So that's the interquartile range, the interquartile range. Now we're going to put them in order from least to greatest. Let me do that in just a snap of the fingers here. All right, so I found a way to do this that kind of sets you up for what needs to come. I did the data values here and the absolute deviations. I wrote the mean. I'm going to write the interquartile range. This might be a good way to do this. And then the MAD to keep everything nice and organized. All right. So first, the interquartile range. Boop, boop, boop. Okay, we came between two of them like this. And now, look, we come between two of them here. You add them up and divide by 2. And you get 16.5 here. Can you see how 16.5 would be between there? So the first quartile equals 16.5. And the third quartile, it's right here. 20 plus 21 divided by 2 is 20.5. So that's 20.5. Now we subtract these values and we get 4. What do we get? 4, I think? 4. So now we have to find the MAD. In order to find the MAD, you got to find the absolute deviations. Absolute deviations. So the mean is 18. I'll find them real quick. The distance from the mean. Now that we have the absolute deviations, we find the mean of those absolute deviations. So you add them up, 6, 7, 8, 9, 10, 13, 18. So now we do 18 divided by 8. 18 divided by 8, we'll find it. and I get 2.25. Oop, did I add them up wrong? 6, 7, 8, 9, 10, and then 15, 18. So 18 divided by 8. Yeah, that should work. 2.25. All right, so it looks like I did something wrong here. Let me just take a look. And I figured it out. I messed up on the absolute deviation. So 18 to 12 is 6. Did you guys catch that first time you saw that? My bad on that. I was rushing through it. But as you can see, there's a lot of room for error in this lesson. So now I have 20 divided by 8, which is 2.5 for the MAD. So 2.5. And then we know that it's about not more than the mean, not less than the mean, but it varied about plus or minus 2.5 from the mean. And not from the maximum, that's for sure. All right, let's go on the next one. So, same thing. We're going to do the same thing here. The data value shows temperatures recorded during a lab test. The temperature of chemical solutions was recorded in degrees Celsius every 7 minutes. What is the mean temperature? So in order to find the mean, I'm going to add these up and divide by however many there are. Okay, and I got 18 again. Would you look at that? No, I said 18. 18, silly. Oh, typing wrong. All right, so now Brianne said the greatest absolute deviation will be found from the greatest temperature. Let's see in this case. 12 is the smallest, 23 is the greatest, 18. So 23 is 5 away from 18, 12 is 6 away from 18. And it would be, I think it's the same data we have up here. This could be the same exact question. No, because the lowest temperature has the greatest deviation, absolute deviation. Yeah, have you ever seen a problem repeat like this? Okay, so the middle 50% is the interquartile range. In the interquartile range, let's see if it's the same as the last problem. Ooh. What is the MAD for the data? Let's see if it turned out to be the same in this case. Yeah, it did. So I think in your assignment, I took out all these problems. I think you only have 7 on yours, 6 or 7, or some of you have 5. I have different levels. Because I know sometimes it does this. Oh, see, my face is covering up the part where it says maximum. No, varied by 2.5 from the mean, silly. There it is. All right. Okay, this looks like a new one. Lydia recorded the liquid precipitation in millimeters every hour during an 8-hour storm as shown. Complete parts A and B. What is the MAD for the data set? Okay, first, in order to find the MAD, we have to find the mean. So we have to first find the mean. Once you find the mean, you have to find the absolute deviations away from the mean. So let's do that now. So we have data values 3, 4, 10, 14, 21, 31, 39, 46. Okay, so here we go. 8 values. Let me count. 2, 4, 6, 8. Yep, 8 values. All right, so first thing we have to do is find the mean. I'm going to add them all up and divide by 8. Yeah, so I got 21 when I did that. So when you find the mean, I got 21, added them up, divide by however many there are. Oh, okay. So there's a mistake because the mean is 21. I was thinking they were going to take a step by step, but we're not to the MAD yet, Mr. Jacobs. The mean is 21. There we go. Now, before we get all trigger happy and go to the MAD, we got to find the absolute deviations away from the mean. Okay, here we go. 21 minus, so that's 18 away. Wow, that's a big absolute deviation. This is 17 away, 11 away. This one is 7 away, 0 away, and 10 away, 18 away, and 25 away. So I found the absolute deviations, the distance from the mean, and now I'm going to add them up and divide by however many there are to find the mean absolute deviation. All right, guys, so here's what I did. I found the absolute deviations. I find the mean of the absolute deviations. So you add them all up and you divide by however many there are. There were 8, and I got 13.25. So that's how you find the MAD. Is there one more question for this? All right. Is the IQR greater than or less than the MAD? What does this tell you about the variability of the data? So now I have to find the interquartile range. We have to put these in order from least to greatest. Oh, thank goodness they did it for us. All right. Finally, we catch a break, right, guys? So there's the median in between 14 and 21. And now you have to, we come between these two here. You add them up and divide by 2. So 4 plus 10 is 14. Divided by 2 is 7. So the first quartile is equal to 7. The third quartile is equal to right here, which is 31 plus 39, which is 70. And then 70 divided by 2 is 35. So now the interquartile range is 35 minus 7, the third quartile minus the first quartile. And that's 28. 28. So 28 is the interquartile range, and 13.25 is the MAD. So is the interquartile range greater than or less than the MAD? So the interquartile range is greater than the MAD. The middle 50% of the data is spread more than the average variation. All right, that's a good conceptual question. Wow, if you made it this far, congratulations. We only have 2 lessons left. Thank you so much for watching, and I'll see you later.